A sub 1 or A subscript 1 are going to be 39 plus 1 minus 1. Is that okay? Times 8. So if you go at it, this is 0. Okay? You don't have to rewrite it. Your teacher will be fine. So this is 0 in between the parentheses times 8. That's gone. It's going to 0. So this whole thing is 0. Okay? Therefore, you're left with 39. Is that okay? That's the first one. You could type that in, of course. Then A sub 2. Now, if you do about 3, maybe 2, you'll recognize the pattern. You may not have to plug in the next, the third one or the fourth one. Okay, but we'll see. So it's 39 plus, see the n? That's going to be your second one, which is 2 minus 1 times 8. It'll be 39 plus, now this is going to be 1. Okay, so 1 times 8. That's 8. Therefore, you okay? It's going to be, you can add them. That's going to be 47. So that's the second one. Here's your first, your second. You can punch that in. Okay. So here's the A sub 3. 39 plus 3 minus 1 times 8. So that's going to give you 2 in between the parentheses. 2 times 8. 16. Okay. And then you add them. That's going to be 50, what is that? 5. And then the last one, A sub 4. Kind of follow me there. So this is going to be 3. You got 39 plus 3 times 8. 24. Okay. So that's going to give you what? 63. Now, if you notice something here, was that 50? Yeah, that's my 55, right? It's, if you notice, arithmetic sequence, it's always increasing or decreasing. It could be decreasing too, by the same difference number, like they call it the D, or by a number. So if you do 47 minus 39, right, you get 8. If you 55 minus, I'm talking like, hey, subtracting between them, 55 minus 47, that's also 8. 63 minus, I should be punching the calculator for you to see, but I think you follow. It's also 8. That means they're all correct. I mean, you did your work correctly. So, okay, you're on to the next one already. You okay? You got that right? Let's go by what they give you. Okay, 36. For some reason, my ink got darker. Okay, here we go. 6. Now it looks different. I mean, you can see what's up. This is going to give you 0 right here. So it's going to give you, because this is 0 times 6. Okay, so therefore you're left with just 36. So this is sub 1, okay, A sub 1. And you get A sub 2. 36 minus 6. What is that? 2 minus 1. So that's going to be 1 in between the parentheses. So it's 6 times 1, okay? So it'd be 36 minus 6. Therefore, it's 30. So you can see this one is decreasing. Can you tell? Yeah, it's going down. So the first one we did was increasing. This one is decreasing. Are we still doing the 4 terms? Yes. So therefore, now if you trust your math, so it's decreasing by 6. Therefore, you can do 30, subtract 6, okay? So that'll be 24. Get it? So that'll be 24 for the third one. And then you do 24 minus 6. You'll get 18. So it's going to be 24 and 18, the last two. Do you understand that? Okay. Yeah. If you trust your math, you did your math at least for the second term correctly, right? Then you should get it. Okay. There you go. Okay, this one. The first 3 terms of an arithmetic sequence are as follows, okay? Okay, you can see it. Go for it. The latter minus the prior, it gives you a -3. Therefore, you can add that to the next one. Is that okay? 8. There you go. 11 plus -3, 8. 8 plus -3, 5. There you go. Good job. Okay. Now, this is also arithmetic sequence. It says it right there. You want to go ahead and find a difference. It looks like it's increasing by 9. Can you tell? It's increasing by 9. Therefore, you do 37. Do you see that? Okay. So 37 plus 9. Okay, what is that? 46. And then 46 plus 9. 55. There you go. Very good. Okay. Now, they're negatives. You just have to carry through. So now if you wonder, okay, I mean, you could probably count it, -9 to -15, from -9 to -15.
It's 6.
6, huh? So you could add -6 to it. Is that okay? Like, it will be -27, okay? And then add -6 to that. Right. Good. All right. These are integers, so you deal with it, right? Just because you see negative and you see positive doesn't change anything. So go from -4 to -1. What do? You add 3. Is that okay? You add 3 to get a -1. If you do -1, you add 3, you get +2. You do +2, add 3, you're going to get 5. So that's going to be 5. And then 8, right? Plus 3. There you go. All right. Okay. See, the common difference, there you go. That's the D. Okay, that's what I was referring to. So you have to read the instruction carefully. It says, hey, for each sequence, determine whether it appears to be arithmetic. If it does, find the common difference. If not, then you say not arithmetic. You see on the bottom there, there's 3 choices. Well, 3 things to look at. Okay, 5 to 1. What is that? You got to check all of it, at least up to the ellipsis, the ... Without you going down by what? Double check. 5 to 1. What is that? By 4.
4. Yeah.
Yep. Subtract 4. 1 subtract 4, 3. 3 subtract 4, -7. -3 subtract 4, -7. So that's correct. So it's going to be -4. Is that okay? Yeah, from left to right. If you wonder, you always do the latter, subtract the prior. So 1 minus 5, for example, 1 minus 5, that's -4. That's your D. So now, is that highlighted? Did you highlight the arithmetic? It's just, it's so weird. It should have been darker. Anyway, okay. What about 14 to 19? The next sets of numbers by, what is that, by 5?
Yeah.
Then 9 to 24, is that by 5? Right? But then what about 24 to 30? No, right?
6.
Therefore, yep. Okay, next one. The last sets of numbers, -4 to -20 by what? By -16. Okay?
Yeah.
But that's a no immediately.
Yeah.
There you go. Yep. So it's not arithmetic. Yeah. Or arithmetic. There you go. Very good. See, double check if it's the same instruction. Yes, it's the same instruction. Okay, so going up by what? 4? 2 to 4, so that's correct. So therefore D is 4. But you always think ladder minus the prior, so 6 minus 2, or 10 minus 6, okay? So there's your D, there's your D. Okay, the next one, 3 to 12. you can always use a calculator, okay? Like 9. So you can tell it's not. It's like, yeah, you can tell that's the next sets. Is that okay? From 3 to 12. But then 12 to 48, that's not arithmetic. It's too big. Okay. What about the last sets? 9 to 4. So you're going down by -5. 4 minus 5, -1. -1 minus 5, -6. So yeah, so this is arithmetic. So D is -5. If you want to show the work, you can do D. Doesn't matter which two. Latter minus the prior. -5. Okay. Okay, now. Okay. You likely have been given thank you for zooming in, a formula for arithmetic sequence, right? Now, if you're not sure, you can always look it up, but do you remember? I just want to ask you first. Do you remember what the formula is?
Let me look at that.
Okay, that's okay. I'll write it. So it's A sub n equals now. Yeah, this is more standard. Okay, more standard formula. You can look at it. Okay, it's a plus. Sometimes they rearrange this a little different. Sometimes they put the D in the front. Sometimes they put it in the back. It's the same thing. Do you remember if your D is in front or in the back? I want to conform to how your teacher go by.
In school, we put the D in the back.
Okay, good. So let's keep the D in the back. So that's the common difference, that D. Okay, so now how do you find this, right? For what do you call it? The 73rd term. So basically you're trying to find A sub 73. Can you imagine that?
Yeah.
So that's like, what is that? Well, you have to find A sub 1, which is the first term. Okay, so the first term, you can go ahead and substitute it. It says right there, 7, the first one. Plus is plus. Now you have to find what n is, and you have to find what d is. Well, n, it's the same n. The n right here is the same thing. Sorry, the n right here is the same thing as n right there. See it? So therefore, it's 73 minus 1, 73 for n minus 1. The d you're about to get, it's just basically subtract the difference between any pair, but do the latter minus the prior. So it's 10 minus 7. That will be your d. Or 13, doesn't matter. Or 16 minus 13. How about that? I'll take the 16 minus 13. So it's going to be 3. That's it. I hope you're okay. So then we do the math. So 7 plus 72 times 3. Now, you can use a calculator here. So, 72 times 3 plus 7. Or 7 plus 72 times 3. You can do that in that order, okay? So it's 223. Okay. Okay, very good. Same idea. Use the same formula. A sub n. I'll keep writing it. So, but you want to kind of be very familiar with it or know it. You do it. You can always write it every single time for exposure, like for practice, for memory, for remembering. So again, 78 A sub 70, the 70th term. The first one, 13, you can see it, plus n is still 70, minus 1. D, you do the latter minus the prior, 21 minus 13. What is that? 8. So that will be your D. You can take any pair, okay?
Yeah.
We continue. 13 plus 69 times 8. So 13 plus 69 times 8, okay, in the calculator. 13 plus 69 times 8. So 565, okay? Wait. 565. 565, right there. We have how many tries? Several?
I think
3?
3.
Okay. Yeah, no problem. Okay, now it gets fancier and fancier so that you know everything about the arithmetic sequence, right? The formula and everything. So they ask you to find the 12th term. You still want to go by the formula. You always kind of write it out and, kind of look at it and what you know, what you don't know, what you need to find. So this is still going to be something you're going to likely use. Okay, 12th term. So therefore, you can kind of like draft it. Here, okay, this is what your goal is. 13, 12, like that. So this is your objective. Okay. So, all right, then it tells you that D. So, okay, so I'll go ahead and, substituting some stuff that I know. D, it's 8. So that's my 8. A1, A1, the first one in the series, they don't show you it, but they tell you it's 5. So right there, A sub 1. So therefore, plus is plus, N is still 12. So you kind of put all the pieces together. There you go.
Okay.
You got 11 times 8. You got 55 plus 88. And 5 plus 88. There you go. 93. 12th term. So it's still arithmetic sequence. So I'm going to write it out. This is great for exposure. You want to know it like by heart. Do you know what the explicit formula is? You have to come up with the formula that looks like this, but your A1 to be substituted and your D be substituted. And then you basically have to, do your algebra by distributing it in. Okay, have a look, okay? I'll show it to you. But I think you'll see it right away. So A sub N is equals to -7. You know that because it's on the list, the first one. Plus N stay N minus 1. D, you have to find it once again. So it's -11 minus, careful, -7. Okay, so it's -11 plus 7. Okay. Are you following okay?
Yeah.
And then plug that in. So it's -4 here. So the formula is like a linear formula. Okay, the explicit formula is basically based off this. So distribute. It's like, like X, unknown, but in this case is N. So -7, do your algebra neatly. -4 times N distributive property here is -4N. Negative times -1. -4 times -1 is a +4, +4. Continue on. Now, I'm going to write the N term first. So, but I'll go ahead and write that first and then combine this with that. So that's going to be -3. I'll put it in the back here. And here's your final answer. Of course, they give you the A sub N, A subscript N. You just have to write this part. Or type in that part. Now, since this is computerized or programmed, you can technically have -3 minus 4N. You can also do that, but it will accept either one, but that's it. Okay, so for more practice, okay, it's just the same. They give you what you need. So based on the formula again, so A sub 23 equals to A sub 1. I gave it to you, 25 plus N again is 23 minus 1. And the common difference is -3. Just be neat here. So -3 times 22, that's -66. and then just combine it. 25 plus negative 66. Use your calculator if you need to. It'd be negative 41. So that should be the answer. You can imagine going from 25 all the way down to negative 41, the 23rd term. This is your A1, your A23. Can you imagine?
Yeah.
Yeah. Okay. Now, like if I try to backtrack and keep the formula, it takes too long, so I'd rather write it. Anyway, okay. So we're fine. Okay, we're doing the explicit formula again, but based off this, I'm going to keep writing it. I think you have this down by now, right?
Yeah.
But yeah, you can always write it for each problem. But of course, if you're doing like a whole page, just write this once for the whole page. And the back page, you write another one like it. So anyway, A sub n is equals to 13, the first term in the sequence, plus n, you keep n as is, 1 d, you have to find it. It would be 10 minus 13, okay? Common difference. So it'll be negative 3. Do your math neatly. Distribute. Be negative 3n plus 3. I'll write negative 3n first. Now you could actually write 16 minus 3n. The program, or it would know. So it'd be plus 16. So here's your A sub n. Okay. Very good. Okay. Find the 12th term. More practice. Okay. Same thing. Use this formula. So A sub 12 equals the first one they gave it to you, negative 3. N be still 12 minus 1. Common difference is 8. Okay. 13. Order operation. Do what's in between the parentheses first. So that's going to be 11 times 8. I'll parenthesize that too to be consistent. Be negative 3 plus 88. So that would be 85. Yeah. So it's going up from negative 3 all the way to 85. The 12th term. Okay. More practice. Yeah, they're really wanting you to be really familiar with it. Okay, then let's do it. Go ahead and do it over here. Use it here. So A sub n equals 14 is the first one. And n is n minus 1. Common difference again. You do d equals, I'll do 28 minus 21. So you eye the pair that it's actually, easiest for you, So therefore it's 7. See that? Doesn't matter, but make sure you take the latter minus the prior, the one that the consecutive, okay, next to each other. The ones that, consecutive. So 7n minus 7. So it'll be, all right, 7n first. 14 plus negative 7, or 14 minus 7 is 7. So here it is, A sub n. Uh-oh. Okay, what did we do wrong? 14, this is the first one. And minus 7. Oh, See, you don't always want to follow me. You want to check my work. 14 minus 7, right? That's not negative 7. I think I said 7, but I wrote negative 7, right? Yeah, you want to look at my work. Yeah, be neat. So it's a plus 7, not minus 7.
Okay.
Maybe that was done on purpose for you to pay attention, right? There you go. Yeah, check my work, check your work. If you can always write it too.
Mm-hmm.
All right, now what do we do? You scroll down a little bit. Yes, thank you. All right, it says graph. So it's a mixture of things here. This is about graphing, and the other one's about arithmetic sequence. Okay, now I think you know how to navigate or use
Yeah,
those
I
on
know
the
how to use
buttons right on the side. Okay, so
it.
you want to start. Do you remember how to do this? Like, there's different ways to do it. Now, the easiest way, if they give you a form that looks like this, right? This is called slope-intercept form. Slope-intercept form. So you recognize to be exactly this. Make sure the x go first, the y goes the x term first, and then minus the constant, like the number, plus, or could be a plus. If you recognize it to be that, immediately you can actually just quick sketch it. How? You go down 7, like negative 7, that's your y-intercept. Oh yeah, your b is your y-intercept. Do you remember that? Like b is your y-intercept. Your m is your slope, your rise and run. So if you wonder where the word slope-intercept, that the compound word slope-intercept. So there you go. Slope and intercept, slope-intercept form. So you start with negative 7. So here's your negative 7. You start right there, putting a point right there. You can go through there if you know how to actually use that thing, but I would actually put a point there, or you start there. How about this? I don't know if you can put a point, but you start right there. Yeah. Okay. Now you're going to rise. Now the slope. Oh, I should write the original here. Now the 3 is 3 over 1, x minus 7. So it's like the numerator is your rise, like you go up. Now rise could be up or down. Run could be left or right. But I recommend you actually, if you get a negative, well, when we see negative, I'll show it to you. So this is going to be your run. But when you run, if they're both positive, you rise up positively, you run to the right. Okay, so you're going to go up 3, 1, 2, 3. So 3, and then run over 1. So this is 1 here. So imagine you rise 3, right? Let me kind of write it this way. 1, 2, 3. And then you run 1. So it's a triangle that you can form. Okay, it looks like this. So the next point, or the point that you're going to go through, or through the grid, it's right there. So it's going to go like that. Oh, don't do a point. Yeah, erase the point. It's just like, what do you call it? It's like the way you form a triangle, but you don't literally use it, right? Yeah, there you go. That would be the answer. 3, run 1. Good. You recognize the method? I think your teacher kind of went over this, right? I hope.
Yeah. She went over it yesterday.
Okay, good. Okay, same idea. Now with the negative, I'll show it to you, okay? I highly recommend you do it certain ways. I'll show it to you right now. Okay, I hope I can back. Okay, back. Good. Because I want to keep that for exposure for you to see. Slope-intercept form. Ymx plus b. Okay, I know the arrow is kind of overlapping that. So what you want to do is that, here's what I recommend you do. You can literally give the negative to the 3 or the 4. Like give it up to the numerator or the denominator. It's up to you. Now, I recommend you to do it in the numerator. Now, you don't have to write it. You could imagine it. You give it up, like attach it to the 3, the numerator, when you do the math, right? 2. Why? I recommend you run, like the rise and run. Here's a rise. Now, your teacher may not be going this way, okay? But I'll show you both ways if you want. It'll be the same graph. It's just going to overlap each other. It's the exact same graph. So the rise, -3, the run is +4. So when it's a negative, say in the numerator, you have to go down, okay? Now, you don't have space, then you actually will change a little bit. You're going to give it up to the denominator. But anyway, if you rise negative, you're going to go down. Well, don't forget, you start at -2 first, or Yeah, starter point -2. That's all right, right there. Not 7, okay? Ignore that one. That's from the last problem. So it's -2 here. Now, you're going to rise, but you're going to go down. Rise could be up or down, you know, and then run. You always want to run to the right. It's easiest that way, you know. So down 3 from -2. 1, 2, 3, like 1, 2, 3. So you'd be right here, and then you move over 4. So it's like a triangle this way and 4 over there. Okay, so 4. 1, 2, 3, 4. So down 3 and run over 4. So the point will be somewhere over here at +4, okay? But you go down, it'll be a -5 here. Down 3, -5. The triangle will be formed here, but of course the line will go through the 2 points. I think you got it. Yeah, that's it. Now, you could have given it to the -4, but that means you have to go up 3. Imagine that, right? And then go to the left 4. So up 3 to the left 4. You see how that works? You see it right there?
Yeah.
It will overlap each other. So we may practice that. They give you another negative. Now, this one is a special case. You know what? I'm going to go ahead and do the whole thing brand new. I can do it fast. Now, you want to memorize this if you can, okay? When they give you a y equals a constant, like a number, or x equals a number, you have to know the difference. It's a straight line that is either horizontal or vertical. So it will make sense if you go through it. You will know it, okay? Whether it's going to be vertical or horizontal. So y is like you think it's on the y-axis, and x will be on the x-axis. I think you're going to get that on the next one, the next problem. So 8. So go up to 8, wherever the 8 is. 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 right here. If you go through it, it will be a horizontal. So you can think of it of this as a special case, a flat line, but not slanted. Okay, so you go through that y, it will be horizontal. If it's x, then it'll go through it this way. Imagine. Okay, so the answer, the graph is going to look like a flat line going through 8. So go for it, like a horizontal flat line going through 8. For a y equals 8, equals a number. So good. Pick any 2 points, I guess. Yeah, any 2 points to form a flat line. Yeah, you can literally do that. Yeah, it's programmed, so you can do any point you want. There you go. That's it. That's the answer. Okay, here we go. Find x and y intercept. Okay. Now, to get your x-intercept, now most often they do a table. The reason why is because, for example, if you're gonna go through this point, I'm making this up. Okay, this is just an example. Okay, if you go through this point, right? Let's say that's 3. That's called x-intercept, but that means your x is 3, your y is 0. Do you get that? The y-intercept, let's say right there, let's say that's 4 up there, right? It means your x is 0, your y is 4. So that's how the x and y-intercept will look, x comma y. So if I do x-intercept, okay, the x-intercept, it means that you don't know what x is, but your y is 0. Get it? So, and vice versa, I'll label it x-int. Here's your y-intercept. Your x is 0, and you don't know what your y is. How about that? So 5x equals 4 times 0 equals 6. Get it? So I plug in to solve for my x. So therefore, that whole thing is 0. That's gone. So you're left with 5x equals 6. Divide both sides by 5. So it's 6/5. So therefore, the x-intercept is 6/5. You can write as a fraction. See, it gave you that option right there, fraction. Same thing for y. Let's take a look at for y-intercept. Oh yeah, go ahead and write that in. Yeah. So y-intercept, x is 0. Now try to take this in. I think you're okay, right? You understand how, based off the example I gave you, you can memorize it if you want. Like, hey, you're trying to find y-intercept, your x better be 0. You're trying to find x-intercept, your y better be 0. So x equals 0 this time, and then you solve for y this time. Okay, so y-intercept will be, you're going to solve for it. So it's gone there. 6 over here from there. So that's gone. Therefore, you're left with, divide both sides by -4. Now we're going to reduce this because we can. So you divide both sides by -4, like divide both sides by -4 here and -4 here. So, and You reduce. Now, if you have a negative in the denominator, it's the same thing as the whole thing being negative. I think you understand that. Also in the numerator. Now the whole thing is negative, so it's going to be a negative fraction. Reduce, divide the top and bottom by 2, will be 3 halves. Okay. So that would be a negative 3 halves. But okay, how do you put that in? Put it in the numerator. There you go. You can put it wherever you want, but it's more common. It's right in the middle or in the numerator. Okay, same way. So we erase the whole thing here. So I don't need to do a table. I think you okay. So let's at least I write this here. But I'll do a table. That's 6. I write 5. I don't keep doing that. Okay. So x, y. So x-intercept, I'll go and write it because it's kind of, and your y-intercept. So you at least, have an idea. I mean, for exposure again, x, you don't know what it is. Y is 0. Y, you don't know what it is. X is 0. So that's your objective. So x-intercept that. So I'm doing this right now. Okay. So your y is 0. So you can see already plus 0 equals 6. I'll plug in 0, So x equals 2. Okay. Divide both sides by 3. So therefore, it's 2 comma 0, or just, yeah. And then y-intercept. Hey, yeah, same thing. You do x being 0. You don't know what y is. You solve for it. That's 0. It's gone. 3 times 0 is 0. So you're only left with y equals 6. There you go. Oh, can I ask? The last one, I didn't pay attention. I'm old. Did you parenthesize or you just put in the number, like the x and y intercept, the numbers, like the x-intercept, y-intercept? What did you do? I forgot. It's a coordinate, right? So you gotta parenthesize that. Parenthesis 2 comma 0, like this, and then 0 comma 6, like that. If you don't, it's gonna mark you. It's gonna tell you something about it for sure. Okay.
Wait, I don't think I can put parentheses in there.
Oh, that means they just want the x being 2 and the y being 6. Is that okay?
Yeah.
So yeah, they're coordinates if you were to actually plot them. Okay, imagine. Oh yeah, this one they want you to. They want you to. Okay, so you're gonna plot the intercepts, both intercept, and you connect them into a line because that's what the equation represent. By the way, if you wonder, okay, if you were to graph this by, let's just say you do the rise and run, it will look the same. Get it? It's gonna overlap. You can solve for y to make it equals y and x plus b. But let me show you quickly, okay? If you solve for y, it subtract both sides by 3x, it will look like this. Therefore, if you go ahead and do the method we did, like hey, go at 6. I know it's not. It doesn't look like right. Let me see here. Is that right? It's not. Okay, it's positive 6, not negative 6. The y-intercept, right? So yeah. Wait. Wait. Are you okay? Yeah. Your plot it's not negative. It's supposed to be positive. The 6 is right. And then you connect them. So yeah, if you graph by rise and run, start at 6 and then go down 3, run 1, it'll be the same. Imagine, right? Yeah. Will overlap. There you go. Okay, very good. Okay. Now, they want you to actually find the slope. Now, there is a formula for it. I think you might recognize it. It's y2 minus y1 over x2 minus x1. It does not matter whether you do, the ones or the 2. Or m equals y1 minus y2. Does not matter. But if you do ones, you better do 1 for the x2. Like the y1s, you better do the x1 first. Now, what does that mean? Well, if you want to make it like, let's just use this one because it's very common. That means the first coordinates, like -8 comma -3, that's your x sub 1, y sub 1. Get it? And then the next coordinate, x sub 2, y sub 2. Like -3, x sub 2, 4, y sub 2. I hope you're okay with that. Let me write it quickly. I think I won't do it on the next one, but this is your x sub sub 2, your y sub 2. And the other one is going to be negative 3, 4. This is your x sub 1, your y sub 1. Get it? Like that's what you want to, eye it at least, or write it if you have to. Now, then use the formula, which is m. So you don't have to write the m in there, just the fraction and simplify it or reduce it if you can. So here we go. I'm going to do y sub 2, which is negative 3, minus, now the minus is mandatory, okay? It's part of the formula. So I'll even boldface that. There you go. So negative 3 for y2 minus 4, right there. And then you do the x same way. X sub 2, which is negative 8, minus, minus, careful, negative 3. Is that okay? You see that right there? Can I ask, do you recognize this? Like, I think your teacher, kind of wrote that up. Yeah. Now, again, you can do this one if you want, but this is actually more common. The numerator is negative 7. The bottom here, then okay. Now, I think you can see, but watch. I'm going to go at it without having to label them. The second sets of numbers, it'll be, x2. The first sets of x and y ones, x sub 1, y sub 1, x sub 2, y sub 2. So here we go. The m, this is for a. You're going to take the negative 2 minus 1 in the numerator. And then you're going to take the 8 minus 8. Okay, now, let me double check my math. There's something going on here. Double check again. Y minus, the two y's, the numerator, right? Negative 2 minus 1, that's correct. And then the denominator, right? 8 minus 8. 8 sub x sub 2 minus x sub 1. Now, do you know what happens when you get 0 in the denominator? The top is negative 3, the bottom is 0. What do you think that is?
Is it undefined?
Yes. Good job. Because if you do the numerator, the 7 minus 7, the top is 0. The denominator is 5 minus negative 6. It doesn't matter what it is, except 0. Careful. So the answer is 0. The numerator is 0. The bottom is it's something other than 0. It's 0. Okay, good. All right, this one. Okay. All right. Okay, this is pretty fancy, but I'm sure you won't have any problem. Just use this, okay? Literally, exact substitution, okay? I'm going to go ahead and substitute. Now, don't forget, m is slope, okay? M stands for slope. So, since they give you m being negative 5/4, so, okay. So it's on the left side. It doesn't have to be on the left side, but since I wrote m equals the y's, the difference of the y's and over the difference of the x's, I'm going to go ahead and do that. So here we go. I hope you're okay. I'll go ahead and write it one more time. Here's the order. 17 comma negative 25. This is your x sub 1, y sub 1. This is your x sub 2, y sub 2. Okay, therefore, the y sub 2 minus y sub 1 will be negative 25 minus r. You agree? You okay? The y sub 1 is r. Like on the bottom here, it will be 17 minus 1. So the top stay as is. The denominator will be 16. This will be negative 5/4 still. Now, there's some fancy stuff that you can do here, okay? But let's just be neat about it. Like even my writing. There's a couple ways of doing this, okay? I don't know. Let me see. If you can look at this and you see that there's a fraction per fraction. The numerator is a unit, okay? They're subtracting, but it's still together, stuck together. You could think they're parenthesized if you want, okay? There's nothing adding on the outside or subtracting away from the fractions, right? One fraction per one fraction. What you can do is cross multiplied. Okay, that's a common thing that students tend to do. If you don't want to do that, then you have to multiply both sides by common denominator of both. Which way do you think you want to do it? Common denominator of both sides is 16. That means you can multiply both sides by 16 and then, you deal with it. Or you could cross multiply. like this and like that. But you better give the negative to something, like the numerator, maybe making a negative 5 out of it over 4. So which way do you want to do?
The cross multiplying way.
Okay, you recognize that pattern, right? That method. Okay, that means just be aware. I'm going to give the negative to the 5. It doesn't have to. It could be in the 4. The answer will work itself out. So I'm going to multiply this across. I'll write it out. It's negative 5. Doesn't matter which side you're going to write, okay? I'm going to write this on the left side. The product of the negative 5 times 16. But careful on this one. If you multiply a 4 and by a 2 terms, a binomial here, you want to parenthesize it. So here we go. Negative 25 minus r. Is that okay?
Yeah.
Okay. Then you do 5 times 16, but it's negative. Negative 5 times 16. So use the calculator if you have to, okay? Just make things quick. So it's negative 80. Distribute. It'd be a negative 100. 25 times negative 25 times 4. 4 times negative 25. Minus 4r. So far, okay? Since the r is on the right side, I'll leave it there. So I'll go ahead and subtract both, add both sides by 100. Okay. So that cancels and you get negative 4r on this side. And this is going to give you 20. 100 minus 80 or negative 80 plus 100. Then divide both sides by negative 4. Therefore, the answer is going to be negative 5. Okay?
Yeah.
Divide both sides by negative 4. Okay, we hope we get that right. Is that good? Okay, that was good. Okay, I'm glad. I'm gonna do the x's right here, and I'm gonna do the y's. What I mean is that, for example, I'm gonna go ahead and write the domain and the range, like the d. I can't do that. That's calculus. So I'll go ahead and do domain and range. You could eye it, but I'll go ahead and be neat about it right here. So it will look like this. Okay, brace, open brace. That's lame braces. Okay, negative 4, negative 1, 2, 5. You don't have to do this, okay? You could eye it, but let me go ahead and show you for, for learning's sake here. And then the y is going to be 1, negative 3, negative 8, negative 11. You can go ahead and look at the difference between them, right? Negative 1 minus negative 4, negative 1 minus negative 4, negative 1 plus 4, so it's 3, okay? 2, I'm doing the latter minus the prior again. 2 minus negative 1, that's 3. 5 minus 2, that's 3. Okay, what about down here? Negative 3 minus 1, the difference, the common difference, okay, I'm doing. Negative 3 minus 1 is negative 4. Careful on this one. Negative 8 minus negative 3. Negative 8 minus negative 3. So that's negative 8 plus 3. So that's going to be a negative 5, okay? Negative 11 minus negative 8. That's negative 11 plus 8. Here, it's going to be a negative 3. Now, they're not the same. It doesn't have to be 3. It just have they just have to be the same. Is it okay? Like the difference. Therefore, this is not linear. The first one. Okay. This is function 1. For function 1. This is we're gonna do for function 2. Again. 3, 4, 5, 6. Okay. You can see this is by 1. Right? You can look at it. So you can eye them too, but okay, 1 here. And the range. Okay. So that you got negative 2, 0, negative 5, and negative 10. Okay. Here, what is that? 0 minus negative 2, that's 2. Negative 5 minus 0, negative 5 minus 0 is negative 5. That's negative 5. You double check if I copy it right. Negative 2, 0. Did I do that right? Are you checking my work? Okay. Like from 0 to negative 2. So this is not linear either because this is not the same. They're not straight out. I hope you're okay with that. Double check my math, okay? You see that? Okay, now for the x's, this is function 2. Function 3. Function 3, okay? Okay, what is that? 0 minus negative 3, that's 3. 3 minus 0, that's 3. I don't want to put comma. And then 6 minus 2, that's 3. Imagine you're doing the common difference here, okay? And then the bottom here, it'll be 4 minus 0, that's 4. 8 minus 4, that's 4. There you go. You see that. I know. Okay, what about the function 4? 9 minus 5, that's 4. 13 minus 9, that's 4. 17 minus 3, that's 4. Okay, now what about 9 minus 4? That's 5. 16 minus 9, that's 5. 25 minus, what is that? 25 minus 16? 25 minus 16, that's 9. So this is not a function. Oh, wow. Okay, they're really, really pushing it. Okay, so I think that's that. Is that okay? Okay, good job. Good job, dude. I'll see you next time. Okay?